All right, we are going to take our knowledge of scatter plots and lines of best fit, and we're going to turn it into a concrete line, meaning we're going to identify the slope of it and put it into slope-intercept form, and then use that line of best fit to make predictions, okay? So the steps, you pick 2 points. Pick 2 perfect points, right? Perfect. That means I don't want you to estimate. I want them to be perfect points. Whole numbers. Whole number. No decimal. Okay? That's what I mean. When perfect points mean don't make it a fraction, don't make it a decimal. Try to make sure they're a whole number. Then we find slope. What slope? Second y minus first y over second x minus first x. That we've done. We've done this before. This is nothing new. It's just a very rigorous application of our concepts. Use point slope, that formula. So that means we have the point and the slope. Okay? That's when we move to point slope. And get it into slope-intercept form. Slope-intercept means y by itself. All right, first one. Step 1 says pick 2 perfect points. So I'm looking to see, okay, what is a perfect point? I'm looking at my line of best fit. I'm not looking at my scatter plot or my scattered points. I'm looking strictly at this line of best fit. Okay? And I don't see an actual, just kidding, I see this point. That's a perfect point, and I see this point. That's a perfect point. A perfect point is anywhere where the grid marks intersect. You know exactly what they are. That's a perfect point. Okay? So now I have to write them. So let's see, I have the point 16, 300, and the point 22, 500. Just writing down what the values are. 16 and 300, 22 and 5, because it goes x, y. X is the bottom. Now I find my slope. Slope is equal to your second y, take away your first, over your second x, take away your first. 200 over 6. I gotta be able to simplify that somehow. I know they're both even, so I can half them. That would be 100 over 3. And that's all I can do. So that's my slope, 100 over 3. Not a pretty slope. Now I pick a point. So I usually just go right to that first one, pick a point. So 16, 300, m equals 100 thirds. Now point slope. Point slope, use point slope. Y minus the y I'm given is equal to my slope times x minus the x I'm given. Uh-oh. Then I gotta get y alone. This is where it gets difficult. I'm gonna distribute my 100 thirds. So when I distribute a fraction, I like to turn the second term into a fraction, because multiplying fractions, you go top times top over bottom times bottom. A skill you need to just remember. So I get y minus 300, show your distribution rainbow, is equal to 100 thirds x minus 1 top times top. 100 times 16 is 1600 over bottom times bottom, 3. get y alone, so I'm going to move my 300. Y equals, so show that we're going to add 300, add 300. This is 300 over 1. So I have to turn, I want to just do this on the side, 1600 over 3 plus 300 over 1. I want a common d of 3. In order to add them, I have to have a common denominator. That would turn this into 900. So now I got 1600 plus 900. 2500. So y is equal to 100 over 3x minus, this turned into, I did my side work, that turned into 900 over, wait, just kidding, 2500 over 3. Done. I made my line. Do you love this line? I don't love this line, but I created it. I knew how to figure it out. It was not the easiest thing in the world, but I can handle it. I use my previous knowledge of fractions, meaning if you multiply fractions right here, this step, multiplying fractions, you go top times top, 100 times 16 is 1600, bottom times bottom. 3 times 1 is 3. And then I knew I had to add 300. When you add fractions, you need a common denominator. So I did some messy work on the side. You never turn it into a decimal. Never. Slope, intercept, and graphing lines is always fraction form. So if you use your calculator to help you, you have to turn it back into a fraction. Does that make sense? Have to. I would just, sometimes it stresses me out changing it a lot, so I would just go right into doing it myself. All right, we're going to do this next one. We need a lot of space for it. Step 1, find 2 perfect points on the line of best fit. So I want you to identify 2 perfect points. I'm just going to make that a line of best fit. Sometimes you might want to estimate it a little bit because you want 2 perfect points. Okay, so I found the 2 perfect points. They look like I have 2 and 120 is one of my points. Point A, if you want to call it. Then my second perfect point looks like it's 8 and 160. That's my second perfect point. Step 1, pick 2 points. Done. Step 2, find slope. So second y minus first y over second x minus the first x. This one might work out beautifully. 160 minus 120 is what, 40? No, it's not going to work out perfectly. 8 minus 6. 6. Not fully simplified, half it. So that'd be 20/3. Okay, have my point. That was step 2. I just follow my steps. Did it? Did it. Okay, use point slope. Well, then I need a point. So I pick the first one. M equals 20/3. Okay, now I'm not done with step 3. I'm still working through it. Here I go. Y minus the y I'm given is equal to my slope times x minus the x I'm given. I did that. Now it comes the annoying part. I have to get y alone. So in order to get y alone, I need to distribute. I see I'm going to distribute a fraction, so I'm going to turn that into 2 over 1. So I can go top times top over bottom times bottom. 20 times 2 is 40, over 3 times 1 is 3. Okay, now add 120. So it's going to be 40 over 3 plus 120, right? 40 over 3 plus 120. So I need space to do that math. 40 over 3 plus 120 over 1. Get a common denominator. 120 times 3 would be 360. Okay? So y is equal to 20 over 3x minus 360 over 3. I think I can simplify that because 36 over 3 is 12, and then you just add the 0. So y equals 20 over 3x minus what? Minus 120. Okay? Done.